Well, hello everybody. Remember last week when I spoke about how the effects of inertia and air resistance when you're falling slow you down or speed you up and how they change your speed? Well, this week I'm going to tell you about forces not when you're falling, but when you actually hit the ground. Why, you may ask? Because it's physics time. Now, having learned what I've been telling you over the last few weeks, have you ever wondered why, when you drop something from higher up, it breaks apart? For example, if you have something made of Lego, if you drop it from a centimetre up, it survives unharmed. If you drop it from an inch off the ground, a few bits might break off. But if you drop it from a window of a second story, it'll smash apart. And now, I bet you're thinking it's because it hits the ground with more force, because it's going faster. But that would be wrong. It has the same amount of force acting on it, whatever happens. As I explained last week, force is the same as mass times acceleration. The acceleration of an object is the same if you drop it from a centimetre or from a window. It just isn't going as fast. Watch last week's episode where I explained all this about acceleration if you're a bit confused. And because the mass stays the same, it must have the same force if the acceleration is also the same. So why does it have such a different effect? Another famous law Isaac Newton worked out is that every action has an equal and opposite reaction. This means that if a bird flaps its wings with 100 newtons of force, the air pushes back on the bird with 100 newtons of force as well. It's all to do with the inertia of an object. It doesn't want to be moved, so it pushes back on whatever is pushing it to make it stop moving it. As the Lego hits the ground pushes back up on the Lego, causing it to decelerate, which is a negative acceleration, i.e. an acceleration in the opposite direction with an equal and opposite force. If I jumped out of a window, we could work out that the force pulling me down, my mass is about 3 kilograms. So 3 times 9.8 meters per second is 29.4 newtons of force pulling me to the ground.
But when I land, I have another force acting on me. I have 29.4 newtons pulling me down and another force pushing me up. Now, this opposite force isn't quite equal. If you hit something with any amount of force, it moves slightly. Hit it with enough force and it moves a lot. But if something has more mass and therefore more inertia, it'll push back on you with more force than you're pushing on it with. So, acceleration is equal to the change in velocity divided by the time it takes for this velocity to change. If I fell from 3.5 meters up, I would have a velocity of about 5.6 meters per second. In less than a millisecond, which is 1,000th of a second, I would decelerate from 5.8 meters per second to 0. The change in velocity is 5.8 meters per second, and this, divided by 1 millisecond and multiplied by my mass of 3 kilograms, means I would have a force of 17,400 newtons.
To recap, the reason things get smashed because you drop them from higher up is because they're going faster by the time they hit the ground, so they decelerate more, meaning it takes more force to make them go down to being still. Because of this higher force, things smash when they hit the ground. It's also because generally the ground and the planet has more inertia and because it has more mass than the object, so it has more force it can hit the object with. So, as always, thanks for watching guys, and I'll see you all next week. Bye.